Newton's method, or the Newton-Rhapson method, is a method we use to get the root of a function, and in this case this function is y or fx, and this is the root. The r there is the root of the function, but we don't know the root yet. Now there are many algebraic methods to do this, but one of the numerical approximation methods is to use the Newton's method, the approximation method. And basically what you do is you start with a guess. You guess x1, that is a root. The x1 has a corresponding y value. The y value you get by substituting the x1 into the fx, and you get the corresponding y value. Now you start with a guess, and then what will happen generally is that with Newton's method is you'll move closer to the r by using a formula, and we'll now derive that formula. To take a good guess, your first good guess, usually they will give you a number to start with, but let's say they say, well, you must take a guess, and then from there on you must get the root of the function. And just a side note, remember the root of a function is where the y is 0 on the graph, so the x value that gives a y value of 0. Now this is the root r here, or some might call it a 0 point or a 0 of the function. But anyway, to get a good guess, you take a value, let's call it let's say x3 there, and because this x3 will give you a positive y value, so it will give you a positive y value, and you take a guess here, let's say x4, and then you get a corresponding negative. Now if you get a negative y and a positive y between 2 points, you know that there's a 0 point between those two numbers, because the y is 0 here at this point. So now you take a guess, for example this x1 that's between the x3 and the x4. But anyway, Newton's method is derived by basically using the gradient method, or to work out the gradient of a line, and you'll see now what it means. Now first of all, the gradient of any line is the difference in y's divided by the difference of x's. Now this means you take 2 points, 2 coordinates on a graph, on a line for example, or on a graph, doesn't matter, but there's the 2 points you take in this situation. You'll see now how we get it, but you get the coordinates of those 2 points. The coordinate of that point there is x1, so the x value is x1, and the y value is fx1. This one's x value is x2, and the corresponding y value will just be 0, because, well, that's on the x-axis, and then the corresponding y value is 0. So then the difference in y over the difference in x just basically mean it's the difference in the y values divided by the difference in the x values, and this is one coordinate on the line or the graph, and this is the other coordinate on the line of the graph. Now in our situation, then we'll calculate now the difference between that point and that point. Now let's just get back to this red line here, let's call it L. Okay, let's call it L. Now the gradient of that line L, okay, we get by, well, first of all you have the y2 minus the y1. Now the y2 corresponds to the x2, so in this situation we have the x2 there, so the corresponding y value will just be 0. Okay, so that y2 becomes 0, minus the y1 is just the y value corresponding to the x1, and that's just that fx1, so you'll say minus fx1 there. Okay, divided by the x2, we can keep the x2 minus x1. Okay, now the reason why we did that, okay, and why we specifically working with this line L is at x1 on the graph you have a point there, okay, but you also have, at that point, you can work out the tangent. And this is the tangent line. This is the line that touches the graph, the fx, at that point. Okay, and now we're just calculating the gradient of that tangent line, and this is the formula we use. M is equal to the difference of y over the difference of x. Use two coordinates on that line to calculate the gradient of that line, and those 2 points we substituted, those 2 coordinates we substituted, we just placed into the gradient formula. Okay, now the next big step is to realize that the gradient of this line L is the same as if we would work out the derivative of the function fx, the derivative of the function fx at the point x1. Because remember, the derivative, if we work out the derivative of a function fx, this derivative describes the gradient at different points on the graph. It describes the gradients of each tangent on the graph at specific points. Now, in our case in point, we want the gradient of that tangent at x1. So all we do is we just substitute x1 in there, and this means it's the same. The gradient of this line L is the derivative at x1. That will give you the gradient at x1. Okay, so now all we now do is we are going to simplify. Okay, so minus fx1, because obviously there was a 0, so there's no more 0. 0 is just 0, you can leave it away. Then you have x2 minus x1. Now we want to get this x2 minus x1 away as a denominator, so we multiply this side with x2 minus x1 and the other side with x2 minus x1. Okay, so we can cancel that out. So we have, well, so let's write it like this: fx1 minus x2. I'm just going to write it. Oh, this is, remember, this is x2 minus x1. Sorry, there. So it's x2 minus x1. You're going to write there, and this is negative fx1. And then we're just going to, oh yeah, then we're just going to divide this f accent x1, the derivative, away that side, and then divided this side. Then you have, you can cancel that out, and then all you are left with, I'm just going to move this bit down so that you can still see it. So then you have x2 minus x1 is equal to, well, it's negative fx1 divided by the derivative of fx at x1, and then you get x2 is equal to x1 minus fx1 divided by the derivative of fx at x1. And now we have x2. So now what's happened now is we have a formula to get x2. So there's the x2, and you can see x2 is now closer to the r. It's now coming closer and closer to the r. So now our next one, x3, all we do is to get the x3 that will now be going closer to the r, is we just put x2 minus fx2 and the derivative of fx and you with at x2, and now the x3 will become closer and closer to the r. So to get a general formula for the Newton's method, it is just the next number. To get the next approximation, you use the previous approximation minus the f at the previous approximation and the derivative at the previous approximation, and then you keep on doing this until you get closer and closer to the root. Okay, so that's how the Newton-Rhapson method looks like and how it works. This is the formula. This is the formula what you will use.